Assalamualaikum and hi everyone. So we are from group 6. We'll be presenting the assignment 2 regarding about the topic 5, which is the divide and conquer, and also the topic 6, which is the decrease and conquer. Before we start, let me introduce you our teammates. So firstly we have me, Asyraaf Danial, with metric number 284366. Then we have MAZUQI ADHA with metric number 285215. Muhammad HADIF with metric number 287852, and last but not least AHMAD AZEEM 288777. So we'll be discussing about the question 1. So for the question 1, compute 2101 times by 1150 by applying the divide and conquer algorithm. So we'll be discussing about the question 1. So to use the divide and conquer algorithm, firstly we need to divide the number first. So here we have the sum of the calculation or step here. So first one, for the 2101 times by 1150. So we'll be using several variables. So we declare it as C2, C0 and C1. So for the C2, we'll be using the first and second digit for the 2101 here. So and then we times by the first and second digit from the 1150. So for the C0, we'll be using the last third and fourth digit from the 2101, and also the third and fourth of the digit 1150 50. So it will be C0 will be 01 times by 50. And then for the C1, we'll be using the 21 plus the 01, and then we will times with the 11 plus 15, and then also we need to minus with the C2 and plus with the CO. So here we will simplify it as the 22 times by 61, and then will be minus with the 21 times by 11, and then we need to plus with the C0, which is the 01 times 50. Next, for the 21 times by 11, same goes, we will be using the algorithm for the C2, C0 and C1. So for the C2, we'll be using 2 times 1, then we will get 2, and then for the C0 we'll get 1 times 1, then of course we will get 1. And then for the C1, repeat the step from the above method. So 2 plus 1 we get from the C2 and C0, and then we minus we be times with the 1 plus 1, and then we will minus with 2 plus 1, and then we will get 3 times 2, and then minus 3, and then we will get 3. So for the 21 times 11, we can say that 2 times by exponent 10 over 2. Why 10 over 2? Because it is the 2 is the second placement of the digit here. So that's why we need to exponent square or exponent 2, and then we'll be plus with the 3 times with the 10 exponent 1. So like I mentioned before, why? Because it is the placement of digit is 1. So that's why we put the exponent as 1, and then we need to plus with the 1, and then we will get the answer for the 21 times 11 is 231. Next, we'll be moving on for the 401 times by 15. So for C2 will be 0 times 5, we will get 0, and then for C0 we will get 1 times 0, we will get 0. So for the C1 we will get 0 plus 1 times with 5 plus 0, and then minus with 0 plus 0, and then we get as simplify 1 times 5, and then with minus by 0, and then we get 5. So we can conclude that 01 times with 50, we will get 0 times with exponent 10 over 2, and then we will plus with the 5 times with 10 exponent 1, and then plus 0, and then we will get 50. So for the last one, we will have 22 times 61. So for the 22 times 61, for the C2 we will get 2 times 6, which is 12. C0 2 times 1, we will get 2, and then for the C1 2 plus 2 times with 6 plus 1, minus with 12 plus 2, and then we will get 4 times 7, minus 14, then we will get 14. So we can conclude that 22 times 16, we will get 12 times 10 exponent 2, and then we will plus 14 times 10 exponent 1, then we plus 2, we get 1342. So we can conclude that for the final step, 2101 times with 1150, we will get 231 times with 10 exponent 4. This is because displacement of the digit here for the last one is 4. So we will plus from 4 1342 minus 231 minus 50. That's from the we do this step earlier before, 231, and then we will minus with from 1342 minus 231, and then minus 50, and then the placement of the digit is 2, so that's why we will times with exponent 2, and then will be plus 50. So then we will get the answer is 2,460,150. So this is the final answer. So
now we move on to second question, which to apply the Streisand algorithm to compute the matrix multiplication. Okay, traditionally, matrix multiplication is performed using the standard algorithm, which has a time complexity of a big O n to the power of 3, where the n is the size of the matrices. However, Streisand algorithm offers a more efficient approach, reducing the time complexity to a big O n log to the power of log base 2 7, which is approximately equal to big O n to the power of 2.81. This algorithm is based on concept of recursive divide and conquer, and it divides the matrices into smaller sub-matrices to compute the multiplication. Okay, now we have two matrices to perform the matrix multiplication. Both matrix has 4 times 4 size, so we can conclude we normally Streisand algorithm must perform 2 times 2. First, we had to divide matrix A into sub-matrices. Because this is a 4 times 4 matrices, so we can conclude that we could use the divide and conquer, which is we split the 4 times 4 into 2 times 2. And now there you go. We had like 4 matrices to based on this matrix A. Now this is the products. Later on I can explain. Now we move on to matrix B as well. Same goes, we divide the matrix B into sub-matrices as well. Alright, we highlight matrix B. We divide them into 4 matrices as well. And there we go. We got 4 sub-matrices from the matrix B. The next step is we had to do a recursive step From the submatrices, we can compute the partial product and resulting the quadrant, and this quadrant later on could be combined and become the solution of the matrix multiplication. Okay, from the resulting quadrant, we can combine this quadrant to become the matrix multiplication to the solution. Okay, to summarize the Streisand algorithm, we conducting that in terms of efficiency, Streisand algorithm offers a more efficient approach to matrix multiplication compared to the traditional method. It can reduce the time complexity from big O n to the power of 3 to approximately big O n to the power of 2.81, making it highly suitable for large matrices. The second point is divide and conquer. Streisand algorithm utilize a divide and conquer strategy by breaking down the matrices into smaller submatrices. This recursive approach helps in reducing the number of computation required. The next point is resulting in partial product and quadrants. The algorithm computes partial product by combining the and multiplying submatrices. These partial are then combined to form the resulting quadrants of the output matrix. In terms of versatility, Streisand algorithm is just one of the many approaches to optimize matrix multiplication. Other algorithms like Coppersmith-Wainwright algorithm and parallel computing can further enhance efficiency. In terms of application, efficient matrix multiplication has numerous applications in fields such as image processing, data analysis, and numerical simulation. Implementing the advanced algorithm like Streisand can greatly benefit this application.
And then for next question is apply the Russian-Peasant algorithm to compute 26 multiplied by 47. So after we get this type of question, the first thing we must do is to label M and N. So here, for example, here I label 26 as M value and 47 as N value, since 26 comes first before 47. And after that, we take the M value here and divide it by 2 until we get 1. And please keep in mind that this process we must ignore the remainder of each operation. So for example here, the first value of M we got 26. 26 we must divide by 2 and we got 13. And 13 here we divide it again by 2, we got 6. And then 6 we divide it again by 2, we got 3. And 3 we divide it again by 2, we got 1. And after we got 1, we must stop. And here we got 5 rows of M value. And after that, we take the N value and and multiply it by 2 until we get the same amount of row of M value, which is 5. So for example here, the first value of N here is 47. I multiply it by 2 and I got 94. 94, I multiply it by 2 again, I got 188, and I multiply it by 2 again, and then I get 376, and then I multiply it again for the last time, I got 752, and then I stop because we have reached the same amount of N value with the M value, which is 5. So the next one after that, we must assume that M and N here as a pair, and the starting value of this pair is decided by M. And then we must label each pair for type what is number begin with. For example, odd and even. For the first pair of row that we got, M value is 26 and N value is 47, and we look at that M value since it is the initial value, and it begins with even, so we label it as even here. And the next value, the next pair of value is 13 and 94, and 13 is an odd value, so we label it as an odd, and the next one is 6 and 188, and 6 is an even number, and then we label it begin with even. And the next one we got 3 is an odd value, so we label it again, we label it as begin with odd. And the last one we got 1 and 752, and 1 is an odd number, and then we must label it begin with odd. So here we got 2 pair of values that begin with even number, and we got 3 pairs of value that begin with odd number. After that, after we have labeled all the pair of value that start with either it start with n or odd number, we list out the pair of value that start with odd number. So we got 3 pair of values here. First one we got 13 and 94, we got 3 and 376, and we got 1 and 752. And then after that we ignore all the m value here, and we take the remainder of n value. We got 3 values of n here, right? So to get the answer for this question, we must add all the 3 values to get the answer. Here we got 94 plus 376 plus 752, and then we got the final answer is 1222.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hadi bin Shuhaimi. My matric number is 287852. We'll be discussing about question 3B, which sound from the standpoint of time efficiency. Does it matter whether we multiply n by m or n by n by the Russian peasant algorithm? So basically, this question needs us to clarify whether the order of multiplication affect the time efficiency of the Russian peasant algorithm. So previous question, Russian peasant algorithm works by going through process of halving the first number that count as m, and doubling the second number which count as n. Then after that, the process of halving. So the Russian peasant algorithm focus on the process of halving until the m is equal to 1. Then the doubling process is stopped. After that, we need to find the odd number, then cross out the even number. So when we find the odd number, we need to sum all the n value that correspond to the m value that is odd. Okay, so the previous question managed to get the sum of n value, which is 1222. So when we multiply the 26 by 47 using our normal calculation, we still get the result, which is the 1222. So this question actually needs us to compare does 26 times 47 or 47 times 26 affect the time efficiency of Russian peasant algorithm. Still using the same algorithm to compute another question, which is 47 by 26. So I'll be showing you the process of multiplication 47 by 26. Okay, actually still the same. We're going still using the same Russian peasant algorithm. You see that the process still going to the halving process going until the m value corresponds to 1, and the doubling process will stop there. So after that, we need to find the odd number, and we need to sum all the n value that correspond to the m value which is odd. Okay, still got the same result, which is 1222. So So basically the number of iteration, actually the number and the order of operand. The order of operand refer to the order of multiplication doesn't affect the time efficiency of Russian peasant algorithm time. This is because the algorithm works by repeatedly halving the first number, which is m, count as m, then doubling the second number until the halving operation reduce the first number to 1. Actually, the process of halving will stop at there until the m is equal to 1. So since the algorithm only involves halving and doubling process, the order of multiplication still doesn't affect the number of iteration or the correction or the computational step required. Whether you multiply n by n or n by m using the Russian peasant algorithm, the time efficiency will remain the same. So therefore, when computing 47 by 26 or 26 by 47, both will resulted same, which is 1222. But the process of this algorithm only depends the iteration of the processing of the halving processing. Forgot to mention that the Russian peasant algorithm time efficiency is big O log n. N is required. N is the number of iterations. What the number of iteration is refer for is the number of times that the first number gone through the process, gone through the halving process. So let me clarify the number of iteration, which is the process of first, this one halving the process 47 by divided by 2, we get 23. This is count as 1. So the next number is 11, count it as 2. This one is 3. This is 4 times of halving process. Same goes to the previous question, which is 26 times by 47. Also the same. We got 1, 2, and 3 times, and 4 times actually. The process halving process. So answering the question, the time efficiency doesn't affect whether we multiply n by m, or m by n by the Russian peasant algorithm. So that's all for me. Thank you.